we kind of were able to figure out the horizontal asymptotes yesterday with the calculator. Yes. But there's an algebraic way, and folks, because I have to confer with Dr. G and say, do we really have to know? You're going to use your calculator. You're going to blow up your calculator, okay? I'm telling you, your table, second table, is going to be your best friend, especially when you're trying to figure out where those asymptotes are, okay? Now, with that being said, look at that little piece of paper I gave you. And we're going to finish up. You may need to take notes on the side there. You may not want to just make this full-blown notes. But we're talking about those horizontal and vertical asymptotes. And there will be some things that are going to be verbatim on that sheet of paper. But then there are some things that I read and I go, what? Because it's just weirded all. It's weirded. It's worded weirdly. And I just kind of scratch my head and go, that doesn't make any sense to me. It may to you, but I have to reword it into something that makes sense to me, okay? So, we were told that any function has two parts. We're talking about our rational functions. It has a numerator and a denominator, and I think it's called a of x over b of x. Numerator over denominator. To find the zeros, we know from yesterday, my crazy thing for me to remember, diva to me means what? And to some of you now, denominator, vertical asymptotes. So, in order for me to find vertical asymptotes, then I'd set the denominator equal to 0 and solve. And I know that diva thing is so silly. I know that. But it helps me. And I know that it will help some of you, okay? Because you are just as odd as I am, and we embrace that, and we're okay with that, okay? Horizontal. There's something else. If we use the denominator, there is something we can do with the numerator, okay? If we were to take the numerator and set it equal to 0, and we solve it, it would help us find the zeros. Now, again, let's face it, how are we going to find the zeros? Let's get real. You're going to use your calculator. So do I. Second calc 0, left bound, right bound guess, and we find it, okay? You need to be able to do that. But just know that you can find the zeros by setting the numerator equal to 0 and solving, okay? So to find the vertical asymptotes, we set the denominator equal to 0 and solve. To find zeros, we set the numerator equal to 0 and solve. And then we've got those horizontal asymptotes out there. And that, if you look at your sheet, is the stuff at the bottom of that first box. And that's just clipped straight out of your book, okay? Let's talk about horizontal asymptotes. And folks, there's really no other way to know this other than memorize it. And I'll be honest, I don't do well memorizing stuff, but I can blow my calculator up and I can figure out where my horizontal asymptotes are. Okay? With that being said, do not stress over the algebra. as long as you've got a working graphing calculator. Are we cool with that? Okay, so here's what that fancy stuff says. To me, there is no horizontal asymptote if the degree of your numerator is greater than the degree of your denominator. There is no horizontal asymptote. And what it looks like, y'all, and we did several of these yesterday, it looks like it approaches the x-axis. Okay? But there's actually no horizontal asymptote. The horizontal asymptote is y equals 0. What is y equals 0? What is that? Think about what that is. That's the x-axis. Very good. If the degree of the numerator is less than the degree of the denominator. Let me make sure now. Numerator less than denominator. Yep, okay. Just want to make sure I'm copying it right. So the horizontal asymptote will be the x-axis if the degree of the numerator is less than the degree of the denominator. And we looked at functions like that yesterday, like f of x is equal to 3 over x minus 1. Okay? And then you got to know this. Muy importante. Let me see. The horizontal asymptote is the line y equals blank if, you'll understand what blank means in just a second. If the degree of your numerator is equal to the degree of your denominator. So how do we figure out what that line is? What y equals what? All right, this is what you'll do. That line, y equals whatever, okay? We get that line from the coefficient, the leading coefficient of the numerator divided by the leading coefficient of the denominator. Let me move this line. That's how you find that horizontal asymptote. It's going to be y is equal to the leading coefficient of the numerator over the leading coefficient of the denominator. Okay? And again, what's our go-to thing? Let's just be honest. It's going to be our calculator. I'm right there with you because I don't do well memorizing. I have to learn it. And I'm very visual, so I have to see it. Thank goodness I didn't have to graph these by hand. Okay? Thank goodness we've got that graphing calculator. Now, there's one other little thing. And this is just, this is FYI. There are things called oblique asymptotes. Because so far we've talked about asymptotes that are vertical. Those are easy. Diva, right? Denominator, 0, vertical asymptotes. Horizontal asymptotes are pretty simple because, again, we look at our calculator. But oblique asymptotes, we got vertical, we got horizontal. What are we leaving out? Say it again. The sides. Diagonal. What about those? Are there such things? Yes. And they're called oblique asymptotes. These will be dotted lines, if you will, that are diagonal. We are not going to focus on these at all, okay? But I can tell you what they're going to look like. It would look like something like this. You still might have a horizontal asymptote, but you may also have something that looks like this. I mean, it's weird. It is very, very, very weird. We're not focused on those. You don't need to worry about those in Algebra 2. You don't even need to worry about those in trig. That is something way beyond us, okay? What determines it? Probably, I would say, and I haven't gotten into it enough, I'm just like 2 steps ahead of y'all, kind of, sort of. I feel like it has to do something with the sign of the leading coefficient. It has to do with the degree. It has to do with, yesterday we observed that when you have was it a trinomial in the denominator, that it ends up being 3 pieces. There are lots and lots of factors. At the end of class today, I'm going to show you how, remember when we looked at graphs and they had that hole in the graph? Like it was a straight line and had a hole. We're going to look at how we're going to start with something crazy looking, and then it ends up being a straight line with a hole in it. Okay? So it looks more complicated than it is. But it's going back to everything you can do with those rational expressions, factoring things out, canceling out factors. There really is a method to the path that we follow in this class. And it's all coming clear to me the farther I get to the end of this course. Okay? That doesn't make any sense. But it won't make any sense until we get there. Question. I want you to look at the function x over x plus 2. And you're going to do a couple of things. You're going to find the horizontal.
Mary.
Yes, ma'am.
If you think Kelly Morgan got the phone off, it's being sent, please.
Yes, ma'am.
Thank you.
Find the horizontal and vertical asymptotes. And then you're going to find the zeros. I don't think I ever spelled this word the same way twice in a row. Oh, well. Nope. No. We have to look at the function f that is not bleached out stinky stink. I know. It was so big, I know. Never see those. It was a wonderful phenomenon that I got to witness, and with my nose first. No. On a picture. I've seen one on a picture. And what about those horizontal and vertical asymptotes? What about those? Let's check these out. Check it out. Check it out. All right. Wow. Oh. Here we go. Oh, thanks. Please, thank you. Random not, that was total. At least you didn't. All right, here we go. Put this in the calculator. Stop being so. I'm sorry, we have an elephant in the class. That's not right. Oh, what do I do? Don't panic. Zoom 6. Zoom standard. Oh, don't panic. Hit enter again. There we go. Okay, folks, we don't know why this calculator shows the asymptote and why some of your calculators don't. I asked the pro, he doesn't know either. We don't know why, okay? But I do know that it said for me to find the asymptotes. So for me to find the vertical asymptote, I'm going to take the denominator, set it equal to 0, and it gives me x equals -2, right on? Let me rewrite that because that kind of looks crappy. X equals -2. So that means my vertical asymptote is at x equals -2. Horizontal asymptote. I'd look at the calculator, okay? But I have notes now that I'm going to have to refer to. The horizontal asymptote said that we have to look at the degree of the numerator and the denominator. The degree of my numerator is what? 1. The degree of, I'm going to put 1D for degree. The degree of my numerator? What's the highest exponent in my numerator? No, I got it from my numerator, which is x to the first power. So that means the degree of the numerator is 1, correct? What's the degree of the numerator? The degree of the denominator is 1, yes? Okay, so the degree of my numerator is equal to the degree of numerator is equal to the degree of the denominator. According to the notes we just wrote down, what does that mean? What is it? The leading coefficient. So what's the leading coefficient of the numerator? 1 divided by 1 is 1. That means my horizontal asymptote is y equals 1. How would I verify it? Calculator, go ahead.
So if they're equal, does it always go into itself?
Not necessarily because they're coefficients. No, we're looking at the degree. Yes. Mm-hmm. Yes. Yes. All right, now. Yep. Bless you.
Another 1 degree?
Yes. No. Look what I did. That's why I wrote it right here. Okay? Bless you. The degree of my numerator, which was 1, is equal to the degree of the denominator, which then took me to the leading coefficient. I had to look at the leading coefficient of the numerator and the leading coefficient of the denominator. Because look back at your notes. All right, here we go. When the degree of the numerator is equal to the degree of the denominator, then we have to look at the leading coefficient of the numerator over the leading coefficient of the denominator. That gives me the line for the horizontal asymptote. Okay? Again, somebody just brought up a good point. What are we really going to do with this? Calculator. Okay, this is all calculator. Now, let's look at it. Clearly, the vertical asymptote is at -2. Do you guys agree with that? If you're not sure and you're thinking because you're just eyeballing that horizontal asymptote, go to the table and look. Go through those values. Look where I am, -46, really? I mean, come on. You can look at it, but then a horizontal line is going to be y equals something, right? So how about this, just for kicks? What do we think the horizontal asymptote is? We think it's 1. Could I do this? Could I put y equals 1, make it a heavier line, and then look at the graph? Aha. I found another way. Ha! All I did was when I eyeballed that picture, when I looked at my graph, and I went, it looks like my horizontal asymptote is going to be 1. Then I went back and I said, okay, well, let's just see. And I'm going to make that, I don't want it heavy. There's my vertical asymptote. Does it indeed have a horizontal asymptote at 1? Yes. It's very clear now. Now, and I just put it in there kind of just as a guide for me. What do? All right, look what it said. We found the horizontal asymptote. Here it is. Ha. Here's the horizontal. We found the vertical asymptote at x equals -2. And folks, you better write it as an equation. X equals a number. Y equals a number. Find the zeros. Oh, Lord. Are we really going to do the algebra? Could you? Look at it. The numerator set equal to 0. Folks, what is x equals 0? Solve it. It's 0. How am I going to verify it? Get your calculator out. Second, trace. 0. Do you see my spider right there? I'm going to go. It looks like it's the origin. I don't know. Left bound to the left. Right bound. Come on now. There it is. Aha! My 0 is the origin. Okay? And now you could graph it on paper. Pardon me? Nope. Because I'm looking for the 0, which is the x-intercept. There's only one place on that graph that curve crosses the x-axis. Okay? All right, so here, let's put this on paper. And it is a sketch, so we're going to have vertical asymptote at -2. I'm going to do this in a different color. And we're going to have a horizontal asymptote at 1. And we found that the 0 was at the origin. So I know it's going to pass through there. And I think it looked something like this. You guys agree with that? Check it with your calculator. Make sure I'm right in my sketch. Right on? Don't make this difficult. I mean, I'm explaining this to death. But let's look at it. Okay, let's look at another example. Something a little bit odd. Let's look at this one. Star-worthy problem. I'll just tell you that right now. Okay? Let's look at the function x to the 4th over 6x plus 12. I want you to follow the instructions. Just follow the instructions. See what You keep working. I'm going to be putting this in the calculator. And it does look strange. This is the advantage that I have because of the asymptotes being visible on my calculator. Do you know how to change that? No, okay. All right. That looks like a flat what? Looks like a flat bottomed what? Parabola, doesn't it? But it does. But what can I tell from this? From my graph, I can tell it. If we had to find the, I always start with the vertical. But how am I going to find the vertical asymptotes? Denominator equal to 0? Did y'all find it to be x equals -2? Pretty clear on my calculator that that's at -2, okay? What about the horizontal? This is when it's weird, okay? Tell me how you're going to figure that out. We've got to compare the degree of the numerator, which is what? The degree of the numerator is 4. The degree of the denominator is 1. The numerator degree is greater than the denominator degree. So what does that mean? There is no horizontal asymptote. And then the zeros, folks. You can go to the graph and find 0, or algebraically, how can we find the zeros? What did it say to do? Set the numerator equal to 0. All right, so my numerator was x to the 4th. Well, how are you going to solve that? 4th root. What's the 4th root of 0? 0. And when you verify that with your calculator, do you not get that the origin is the 0 of that function? Okay? Do I have to do anything else? Nope. I've done everything that it said to do. I found the horizontal asymptote. I found the vertical asymptote. Weird, weird, weird looking graph. Do you agree? Strange. That's what I expect you to do. Put it in the calculator. Because, Christian, guess what I'm going to do? Put it in the calculator. Okay? That's what I'm going to do. Hey, let's look at another one. Things are getting ready to change a bit, right? What if we had f of x is equal to x plus 5 over x squared plus 2x plus 15. Nope, minus 15, my fault. Minus 15. I kind of gave you this problem last week in that hot notebook stuff, okay? But it would have said, simplify this rational expression. How would you simplify this? What would you do? You'd factor. You would factor what could be factored. All right, check this out. X plus 5 can't be factored, can it? We're going to factor that trinomial by unfoiling. Give me 2 factors of 15 that when I subtract, give me 2. 5 and 3. My signs are different. Which one's going to be plus? The 5. What's happening? What's that mean? Cancel out common factors. Oh. It's got an x plus 5 quantity on the top. Cancel it with the x plus 5. What does that leave? That leaves us with 1 over x minus 3. Now let's look at this. Get your calculators. Check this out. Let's put the first one in the I tell you what, half of you, which is going to be my two little rows, okay? That's not really half. That's really a third. I want you guys to put in your calculator the original function, x plus 5 over the quantity x squared plus 2x minus 15. The vast majority, you three guys, 3 rows, what do I want you to put in the calculator? I want you to put the simplified function, 1 over x minus 3. Now, before you do anything, what do you think is going to happen? It's going to, why? Because it is the same thing. This is like having 100 pennies and a dollar bill. Do you get that? That's like, woo, that's a bunch up there. And it's pretty simple down here. Put it in your calculator, see what you get. I'm going to put it in both ways. Be sure you are parentheses, ninjas. All ready? No, you don't have to. I just want to, I'm doing this for a reason. All right, here's the first one. Okay. And then the second one. This is actually tracing the curve. This is the 1 over x minus 3. Oh, look. Look what it's tracing. The same thing. When you get that blinking circle, that's like a tracing tool. It traced the same thing. So it is the same function, folks. Now, what are we going to do with that? What are we going to do with it? Well, what can you tell me about it? Let's graph it. Clearly, it had a what? A vertical asymptote where? At 3. Why? Because if you look at the simplified version, the vertical asymptote, when you set that denominator equal to 0, is at x equals 3. And then, look back at it. Okay. Does it have a horizontal? It's the x-axis. All right. Algebraically, how would we figure it out? The degree of the numerator is 1. Degree of numerator is 1. The degree of the denominator is 2. What happens when the numerator degree is less than the denominator? It means that the x-axis, or what is that equation? The x-axis is the equation y equals 0. So your horizontal asymptote is at y equals 0. So you may want to, I'm going to do my asymptotes in green. And I'm going to draw my curve, my function in blue. I have to look at it again because I forget. So it's going to be here. Is there something else that I could be very particular about when I'm sketching this? There's one other thing I could be real particular about. Where it crosses the y-axis. How would I find that? Just out of curiosity. Find the x value, okay? Find value, x equals 0, enter, and it would give it to you. What do you think? Questions? Comments? Facile or difficile? I see. Did I tell you to find 0? No, I didn't. No. But that's it. What do you think? What about this one then? This example 4. Here's another one. Graph f of x is equal to x squared minus 9 over x plus 3. going to do? Talk to me. Factor the top. How will that factor? X plus 3, x minus 3. Ooh. What happens now? They cancel out. So what am I left with? What is x minus 3? It is my numerator. It's over 1. But it's actually just plain old x minus 3, isn't it? What is x minus 3? What kind of function is it? What is it? Say it again. It is a linear function because it's a straight line. And if you didn't know that, then let's look at it. Now, something's going to happen. I don't care which one you put in there. Actually, I do care which one you put in there. Put the top one in there. Okay, x squared minus 9 divided by x plus 3. It appears that it's just a straight line, doesn't it? But let's look at the table. Okay. Hopefully you are not at negative 137. Oh, what happened? What's that mean? Oh, there's a hole in this graph, but we can't see it. Let's see, second value. Let's see what happens when x is 3. Oh, well, it tells me it's at 0. What do we do? Here's what you do. We're going to graph x minus 3, 2, 3. Our y-intercept is at negative 3. Our slope is 1, so we're going to rise 1, run 1, up 1 over 1, up 1 over 1, 1, 2, 3. But what's going to happen, folks, is there is a hole. What? Say it again. Where x is negative 3. Why? Look back at the table. Because if you look at the table, it says when x is negative 3, and if I were to graph this line, when I get to that point where x is negative 3 and I drop down, there has to be a hole in that graph, and then it continues on. My beautiful straight line, beautiful. We have to think about that table, folks. What is that called? That point there, that hole in the graph. The hole in the graph, look back at that sheet that I gave you. This hole is called a point of discontinuity. How are you going to know that you get one? How are you going to, because if it were me, would y'all think to look at the table if it were a straight line? I wouldn't. But what would be the clue? What would be the clue? When I find where this function is undefined, okay, actually let me write it right here. The point of discontinuity is that point on or in the function that makes it undefined. Okay? The function is undefined at that common factor. And our common factor was that x plus 3. Set that x plus 3 equal to 0, and what do you get? It's undefined at x equals -3. Bless you. Okay? Second table is your friend, I'm telling you. Love it. Love that option on the calculator. So it tells me a lot about my graph. And then I have to think about it, and I have to ponder on it, and I have to look at the graph, and I go back to the table, and I look at it, and I put it on paper, and I look at it some more. This definitely makes you think, okay? Now, again, what would make me think, because if I put this in my calculator, folks, x squared minus 9 divided by x plus 3, and I get a straight line, you ought to know that you need to look at that table. You ought to know that there's a point on there that's going to put that hole in that calculator. And that's when I would verify with that table. Questions? Any questions at all? Where? Right here? Because that was my denominator. That's where my function will be undefined in my original equation. Yep. Okay? Questions? That's that point of discontinuity. The hole in the graph, folks, is where the function is undefined. Okay? All right. Moving, we're taking a whole different route. We're going to start on section 9.5. No, we're not. Dang it. We're going to look at our workbooks. For real? Crap. All right. Folks, bear with me just a moment.